Hello, very good morning to all students of B.Sc Part 2. This lecture is for B.Sc Part 2, Organic Chemistry, Paper 2, Unit 1. This lecture is regarding infrared spectroscopy. It is video 118 and lecture 1. This infrared spectroscopy, or we are saying in IR spectroscopy, or it is also known as vibrational spectra or vibrational spectroscopy. Introduction. Infrared light is when passed through a sample, some of the frequencies are absorbed while other frequencies are transmitted through the sample. See here. This is the range of IR. This range 50 inverse centimeter to 667 inverse centimeter. This range is known as far IR region, or it is useful for metal inorganic or inorganic ligands. It is a stretching and bending. Frequencies are observed, whereas in 667 inverse centimeter to 4000 inverse centimeter, this range is known as mid-infrared region, or it is normal. 4000 to 12,500 inverse centimeter range is known as near IR range. And above this range is known as UV visible range. This near IR range, this is 4000 to 12,500 inverse centimeter. It is useful for detecting protein or analyzing protein, moisture, starch, oil, lipids, cellulose, grains, and oil seeds. Infrared region, this is a 667 to 4000 inverse centimeter, is used for detection of bonds, carbon-carbon single bond, carbon double bond, and carbon-carbon triple bond, carbonyl C double bond O, OH, NH, CO, stretching, etc. in an organic molecules. Energy of electromagnetic radiation is directly proportional to the wave number. E is directly proportional to wave number. When infrared radiations fall on the sample, the molecule undergoes a specific vibrational transition, mu0 to mu1, and energy absorbed, which results in the appearance of an absorption band in the spectrum. See here, IR, this is the source, and this organic or sample, chemical sample, and then light is transmitted from the sample. So certain frequencies of IR is absorb or retain specific frequencies and allow the rest to pass through the transmitted light. And then detector. This transmitted light is detected by the detector, and by doing so also reveals the values of the absorbed frequencies. So here two types of observation we can do. Absorption of IR radiation. When it is absorption, we will record as a absorption. We will get this type of spectra. While when we are recording transmitted, then we will get this type of spectra. Molecular vibration. The atoms in a molecule is not a rigid assembly, but vibrate. Due to the vibrations in the molecule, bond length or bond angle may increase or decrease. Modes of vibration. Stretching vibrations, they may be symmetric or asymmetric. Bending vibration, scissoring, rocking, wagging, twisting. Stretching vibrations. When vibrations occur due to change in bond length of the atoms is known as stretching vibrations. These vibrations require high energy than bending vibrations. These vibrations are of two types, symmetric and asymmetric. Symmetric stretching vibrations. When the movement of the atoms with respect to the particular atom in a molecule is in the same direction, then stretching is known as symmetric stretching vibrations. See here. Here, this is when it is stretched or compressed symmetrically at both ends. It is called symmetric vibrations. Asymmetric stretching vibrations. Here, one atom approaches to the central atom while the other departs from it. See here. Then types of bending vibration, scissoring. In this type of two atoms approaches in plane bending each other. Rocking. In this type, the atom's movement takes place in the same direction or swing in plane. Twisting. Out of the plane bending. Vibrations are those in which atoms twist out of plane. Wagging. Two atoms move up and down with respect to the central atom. Infrared radiation is largely thermal energy. It includes stronger molecular vibration in covalent bonds, which can be viewed as springs holding together two masses or atoms. Specific bonds respond to the or absorb specific frequencies. Thank you very much for today's lecture.